Okay, what we're going to look at now is when our quadratic functions are written in a different form. Until now, they've always been in the general form, which is fx equals ax squared plus bx plus c. Okay, but what we're going to look at now is when the formula is in the form fx equals a x minus d x minus e, and d and e are obviously values. Okay, this is what we actually call intercept form. Okay, and the reason for this is that if we want to find the x-intercepts, then this is the easiest way to find them. Okay, and we're going to talk about why now. Okay, so let's say that we want to find the x-intercepts of this particular one, okay, using the d's and the e's and the a. Okay, if we want to find the x-intercept, we always let y equal 0. Okay, so in this case we would have 0 equals a x minus d x minus e. Now here we have a situation where we have a times b times c equals 0. Okay, and in this case r equals 0 is on the other end. So we have 0 is equal to this. Now we know that if you multiply two things or three things to get 0, one of them must be 0. Okay, to get a 0, you must multiply something by 0. Now, a can't be 0. Okay, and the reason for that is if a was 0, yeah, we don't have a quadratic equation anymore. So we know a can't be 0. B can be 0, however, and so can c. So in this case, we have x minus d equals 0, or x minus e equals 0. Okay, same as what we've done before. Now if we add d to both sides here, we get x is equal to d, or x, in this case on this side, we're adding e, so x is equal to e. And you can see that these are our intercepts. Okay, so our intercepts are d, 0 and e, 0. Okay, so if you have a formula in this format, you can easily find the x-intercepts. Now, let's have a look one step further. If we wanted to find the y-intercepts, okay, now for the y-intercept, we know that we make x equal to 0. So let x equals 0. All right, now typically I'd rather do this with an example equation. So let's say that we've got fx equals 2 x minus 4 x plus 3. Let's say that this was our equation. Okay, if we want to find the y-intercept, some people would be tempted to expand the brackets and find out what that number on the end is. Okay, but you're making it more difficult for yourself than you need to. Okay, so we can just have the function of 0 is equal to 2, 0, whoops, this was not a plus, it was a minus, 0 minus 4, 0 plus 3. So all I've done is I've replaced the x's with zeros. So we have 2 times 0 minus 4 is minus 4, times 0 plus 3 is just 3. Okay, which becomes 2 times minus 12, which is minus 24. All right, and this is how we find the y-intercept. So in this case, our y-intercept is 0 minus 24. Okay, our x-intercept for this formula, you can straight away just look at the formula. It is in a x minus d x minus e. Okay, and we can see that d is 4. So x is equal to 4, or x is equal to, and you need to be careful here, we have a plus 3, so x is going to be equal to minus 3. Okay, if we put minus 3 in place of the e, it will become plus 3. So our x-intercepts are 4, 0 and minus 3, 0. Now with this information, we can think about how to graph this function. Okay, so we can graph this. We so far know, and I'm going to start drawing a little sketch here. And remember, when we draw a sketch, it doesn't need to be perfect. Okay, I'm not looking for perfect sketches. I'm just looking for the information that we need. Okay, so we have an x-intercept at 4. Let's say that this is 4. Doesn't matter where it is. We have an x-intercept at -3. So this is going to be -3. And we have a y-intercept. Let's make it a little longer, just to make it clearer. We'll make our y-intercept down here at -24. Okay, so we found these so far. There's one more thing we need to find in order to graph a quadratic equation or to sketch one, and that's the vertex. Now the vertex, firstly, the axis of symmetry is halfway between the x and the y axis, the x-intercepts. Okay, so we have -3 plus 4 divided by 2, which is -3 plus 4 is 1 divided by 2, so we have a half. So the axis of symmetry is x equals a half, and our vertex is where we substitute this x is a half into the formula. Okay, so we have the function of a half is equal to, so we had 2, a half minus 4 times a half plus 3. Okay, so let's have a look at what we get here. A half minus 4 is, so we have 2 times minus 3.5 times 3.5. Okay, and 3.5 squared, or 3.5 times minus 3.5 is equal to minus 12.25. So it's 2 times minus 12.25, which is equal to 24 or minus 24.5. Okay, so we know we have a vertex somewhere here, and this is a half minus 24.5. Okay, so we've now labeled all the interesting points here, and all we need to do is draw our parabola in through these points, and there we go. We have our parabola. Okay, and I didn't label the axes, so this is x, this is y, and our parabola is fx is 2x minus 4 x plus 3. Okay, and this is roughly what it looks like. Okay, you can see it's just a sketch. I definitely don't want to see anybody using rulers for this. Alright, you know that parabolas have a curve. My curve's not very good looking, but you guys are better at drawing these than I am. Please make sure you're careful with it, and you should end up with something that looks like this. Okay, so when you have to graph a sketch from a function like this, straight away you can get your x-intercepts, your y you can find quite easily, axis of symmetry, vertex. So it's the same process we've been doing for sketching other quadratic equations. Okay, but in this case it's actually much easier to leave it in the form it is in. Okay, the final thing you may need to do is convert it to the other format. So if we take this parabola that we have, which was fx equals 2x plus 4, wasn't it? No, it was x minus 4. X plus 3. If we want to turn that into fx equals ax squared plus bx plus c, all we need to do is expand the brackets. Okay, you need to be a little bit careful here because we have the 2 out the front. So keep the 2 and then use brackets. Our first combinations are x squared plus 3x. Then we have minus 4x minus 12. Okay, so we have 2x squared. 3x minus 4x is minus 1x times 2, so minus 2x minus 24. Okay, and this is that same quadratic equation but in the general form. Okay, so it's very important that you can easily change it from the factorized form into this form. Okay, but fairly easy, just expand the brackets, be very careful with your coefficient a.